Isn't it a pain when your calculator gives you the wrong answer even though you've done everything right? I think it is. When it comes to trigonometry, you can often be sort of stumped by the different units that are used. So up until now, you're very used to using degrees. So a quick way to check on a calculator if it's in degrees or not is to remember that sine of a half, whoops, sorry, I've gone and stuffed this up. Sine of 30 degrees, equals a half. So if you want to check your calculator, do sine of 30 degrees. If it equals a half, you're in degrees. So let's do it now. So let's get out the calculator page. Trigonometry, sine of 30, this should be a half. And it isn't, so I'm not in degrees. So let's go into menu, 5 for settings, document settings please, and here says angle. I'm actually in these things called radians. Okay, so what are radians? So we're going to spend the rest of the video talking about these new things called radians. Okay, now the symbol for degrees, of course, is this little closed circle. The symbol for radians is like a half circle, or a C, if you like. Whoops, almost poorly drawn there. The C. Some people use a little R. Sometimes calculators will use a little R, but it's better habits to get into the C. And also later on, you will develop an appreciation for radians, and just like the rest of mathematicians, you will actually start to use radians as your default units, your default unit for angles. So units for angles, I guess is what we're doing here, units for angles. And because radians will start to be your default, you'll probably start to leave off any symbol at all, but it's a good habit to get into to use this little sort of C in the corner instead of the degree sign. So why do mathematicians like radians? And the answer is that they're more mathematically elegant. So let's suppose that we have a unit circle. What a unit circle is just a circle that has a radius of 1. So here's my, whoops, that's a bad start to drawing a unit circle. So here's my unit circle, and you see it's got a radius of 1. And what if I want to calculate the circumference of this thing? Well, the circumference is given by the formula. So the circumference of this thing is equal to 2 pi times the radius. Now for us, our radius is 1. Here's our radius, it is 1. So for us, distance around this circle is 2 pi times 1, which is 2 pi. So what mathematicians thought was, well, let's define our angles. Let's define our angles here based on the circumference of this unit circle. So they said, well, let's make a full circle. A full circle obviously means we're taking into account the entire perimeter, the entire circumference, if we do a full circle. So let's say that an angle, the full circle angle, that angle there of the whole thing, is equal to 2 pi radians. So in other words, they've said, instead of 360 degrees, which is a weird number really, isn't it? Where did that come from? Instead of that, we will have 2 pi radians. So 360 degrees equals 2 pi radians. Well, if you want to get rid of this factor of a 2, you could just say, like, halve everything. 180 degrees is therefore 1 pi radians. So if you have if you have some sort of angle, let's So if we're going from degrees to radians, what you've got to do is, well, to get from 180 to pi, what happens is, well, we need to get rid of the 180, so we're dividing by 180, but we also need a pi there, so we have to times by pi. So what we're doing to get from degrees to radians is we're timesing by pi on 180, and if we want to get the other way, well, you can divide by pi on 180, in other words, do the opposite thing, and that, of course, is the same as multiplying by 180 on pi. Sort of the same thing. So let's do one or two really quick examples, I guess. First, let me point out that okay, let's have 90 degrees in radians. So we're going from degrees to radians. So that's going to be 90 times pi divided by 180. So 90 divided by 180 is going to be a half. So it's going to be pi on 2. So this value up here is going to be pi on 2 radians, so directly up. Now let's look at 180 degrees is going to be 180 times pi on 180. These will cancel out, so that equals pi. So here we've got pi radians instead of 180 degrees. And pi on 2 is 90 degrees here. Now going directly down, what used to be 270 degrees, we could have 270 times pi on 180. And what you're going to get there is 3 pi on 2. So this is 3 pi on 2. And of course, 360 is 2 pi radians. Now a couple others. Let's look at pi on 4 radians in degrees. So now we're multiplying by, so in degrees, that is pi on 4 times 180 on pi. Pi's cancel out. We've got 180 divided by 4, which is like halving it, then halving again. So that becomes 90 on 2, which equals 45. So that's 45 degrees. So we've got, 45 degrees is pi on 4. So there's a bunch of examples. You can do a whole lot more yourself. Maybe two other key ones perhaps is that 30 degrees is pi on 6, 60 degrees pi on 3, and then there's 45 pi on 4. Okay, so 3 key ones, definitely remember those. Everything else you can just sort of work out on the fly. There we go, that's all radians are. Pretty straightforward. See you later.